started. Okay, so we have a circle that has center B and it has a point A that lies on the circle. What we have to do first is we have to find the equation of the circle. We have the center, somewhere like x minus 5 whole square plus y minus 1 whole square. We know that A lies on the circle. Lies on the circle का मतलब ये होता है it lies on the circumference. It lies on the circumference of the circle. So if this is a circle, let's assume this is a circle. Point A lies on the circumference. It doesn't mean it lies anywhere inside the circle. It lies on the circumference of the circle. Okay. So आप क्या कर सकते हो? आप radius find कर सकते हो by finding the distance between the center and that point. AB का distance find कर लें. That will be the radius. That's square root of 45. So you have 45 on the right side here. That's the equation of the circle. ठीक है? So I'm going to try and do this a bit quickly today ताकि हम ज़्यादा से ज़्यादा questions discuss कर सकें क्लास के अंदर. So the parts that we know about, we can just use their answers directly or do them very quickly so that we can do more questions. Okay, so that's the first part. And the second part, it says point C is such that AC is the diameter of the circle. Point D has these coordinates. Show that DC is a tangent to the circle. How can we do that? How can we show that DC is a tangent to the circle? Remember the properties of a tangent. Tangent kya hota hai? How do you understand a line being a tangent to a circle? So kya matlab hota hai? Okay, so that's a good point. So one thing is that a tangent is always perpendicular to the radius. Okay, so if we can prove that the line DC is perpendicular to this radius, so we know that C lies on the circumference, right? Points mark kar lete hain. So the point B is the center. B is going to be here. This is 5 and 1. If this is B, A is -1 and -2. So towards the left and downwards. So A is going to be somewhere here. Let's say this point is A. Where is C going to be? AC is the diameter. That means agar hum A se ek line draw kare that passes through the center and goes to the other side there, that is where our point C is going to be. So point C is up there. That's the point C. So this is the point C. Now there's a point D somewhere. It has coordinates 5 and 16. 5x coordinate है यानी कि इसी के ऊपर होएगा और इसके बाहर कहीं पे it may be somewhere there, right? Let's say this is the point D. And the coordinates of D are 5 and 16. These are 5 and 16. We have to prove that DC is a tangent. So one thing that we can do is we can prove that the line CD is a tangent, is basically a perpendicular to the radius. हम एक चीज तो ये prove कर सकते हैं, ठीक है? That CD and BC are perpendicular. That's one thing. But is that enough? Is that enough? Because we know this line, for instance, I've drawn another line here. This will also be perpendicular to this radius. Won't it be? So we have this radius, we've got this line. They're also perpendicular, but that line is not tangent to the circle. So that's not enough. We need one more condition. What's another condition for a line to be a tangent to a circle? It touches the circle at one point, right? It has to touch the circle at some point. It can't just be, anywhere outside the circle like this. It has to touch the circle at a point. So these are the two conditions that we have to basically show, that it touches the circle at one point. How can we show that? We know that AC is the diameter, so that's pretty. So आप इसे statement लिखनी होगी, इसको show करने की जरूरत नहीं है. You just have to write the obvious that since AC is a diameter, AC is diameter. That basically implies that C lies on the circle, right? C lies on the circle. That's one thing. The point has to lie on the circle. We have written that down. The second thing is that can you all hear me still? Okay, so there is something wrong with my computer. Got stuck. Okay, it's working again. All right. AC is diameter, so that basically shows that C lies on the circle. That's one thing. ये आपने एक चीज show कर दी, ठीक है? The other thing that you have to show now is that BC and CD are perpendicular. ये आपने show कर दिया अगर, so that will be enough, right? That will be enough to show that it's a tangent. Is that point clear to everyone? Now we have to show that BC and CD are perpendicular. Now for that, we need the coordinates of C first. How can you find the coordinates of C? How can you find the coordinates of C? Any idea? Remember, we have the coordinates of A. A is -1 and -2. We can use the vector method, right? Or the midpoint formula, whatever you want. B is the midpoint of A and C, right? So B is the midpoint of A and C. That means we can say if the coordinates of A are -1 and -2, and the coordinates of B are 5 and 1, then C can be found using the vector method. We can just find the distances. -1 से 5 पे जाने के लिए, what do you have to do? We have to add 6. Similarly, to go from -2 to 1, we have to add 3. We do the same thing here. We've got +6 and we've got +3 here. What do we get? We get 5 plus 6, that's 11. And 1 plus 3, that is 4. These are the coordinates of the point C. ठीक है? ये हमारे पास C आ गया. Now what we can do is we can find the gradient of BC and the gradient of CD, and we can show that they are negative reciprocals of each other. So we have the coordinates now, A, B, and C. Let's find the gradient of CD. What is that? D was 5 and 16. Let's write that down inside. D is 5 and 16. So the gradient of CD is going to be 16 minus 4 divided by 5 minus 11. That's 12 over -6, which turns out to be -2. Okay. So we have the gradient of CD. Now we can find the gradient of BA as well. In fact, BC, that's the radius. BC, find kar le. What is that? That's 4 minus 1 divided by 11 minus 5. And that is 3 over 6, which is 1 over 2. So that's the gradient of BC. We have the gradient of CD and we have the gradient of BC. We have the gradient of CD and we have the gradient of BC. That's -2 and 1 over 2. Okay. How do we show that these are perpendicular to each other? We say, let's find M1 into M2. That will turn out to be -1. You can either, multiply the two gradients and see if the result -1 out there. That's one thing you can do. And the other thing is that you can say, you can write it down in words. You can say gradient of CD and the gradient of BC are negative reciprocals of each other. Right? We can write it down like this. They are negative reciprocals of each other. Since they are negative reciprocals of each other, that basically implies that CD and BC are perpendicular. ठीक है? CD और BC एक दूसरे का perpendicular है. Since they are perpendicular, that implies CD is a tangent. Okay, question on this. Let's look at the last part then. The last part says the other tangent from D to the circle, it touches the circle at E. So there's a point E where it touches the circle now. Let's copy that figure here. So this is what the situation looks like. So there's another tangent that is coming from the point D. So there was one tangent here, the right side पर जा रहा था. Let me draw that again here. There's one tangent here that's going from D to C. Okay. So the other tangent from that point D will be going like this. We're going on the other side here. Okay, so this may be the other tangent that touches the circle on the other side. Okay, it's not very accurate, of course, but you understand the point. We already have the coordinates of C now. We already have the coordinates of C. The coordinates of C are where were they? 11 and 4. So we have the coordinates of C, which are 11 and 4. What we have to do is we have to find the coordinates of this point E. Right? So there is another tangent coming from D that touches the circle at the point E. So उस D से हमारे पास एक और tangent आ रहा है on this side, and it's touching the circle at the point E here. We have to find the coordinates of this point E now. Now there's something interesting here, and that is we see that the center's x coordinate was 5, and the x coordinate of D is also 5. What that means is that the point D is vertically above the point B. वो बिल्कुल उसके ऊपर है यहाँ पे. Right? It's directly above the point B. It's vertically upwards there. Since that is the case, it means ये जो C का हमारे पास y coordinate होएगा, जिस point पे ये C को touch कर रहा है, that's exactly going to be the point in terms of the y-axis where this point E is, as in they are the same horizontal level. The point C and the point E, they have to be at the same horizontal level. Why? Because the point D is directly above the center of the circle. बिल्कुल circle के center पे है. तो एक line वहां से left पे जा रही है, एक line वहां से right पे जा रही है. The point where the tangents touch the circles, they have to be at the same horizontal level. If they are at the same horizontal level, what that means is that their y coordinates are the same. So if the y coordinate of C was 4, the y coordinate of E also should be 4. Is that point clear to everyone? Is this point clear? Okay, so once we know this, once you understand this, the y coordinate is 4, once you understand this part. Now think about it. This is the center. If I were to draw a line here from D to B, or in fact, let's just draw this chord here from E to C. This is the chord, right? EC. If a line comes from B to this chord and it cuts at the midpoint, this is the horizontal line. Since the angle is going to be 90 degrees, this is going to be a vertical line. And the chord is going to be divided into two parts, two equal parts like this. That means the center is exactly in the middle of point E and point C as far as their x coordinates are concerned. So अगर आप horizontal movement देखें, horizontally, since they're at the same level, D and C, E and C, they are the same level, E and C, they are the same level. Center is directly in the middle of them. center is directly in the middle of them. So what you can do is you can think of it this way. What is the x coordinate of the center? The x coordinate of the center is 5. What is the x coordinate of C? The x coordinate of C is 11. So looking at this from this perspective, the center बिल्कुल दरमियान में है E और C के in terms of its x coordinate. X coordinate of the center is 5. X coordinate of C is 11. What do you think should be the x coordinate of the point E? वो क्या होना चाहिए? -1, right? And how do you know that? Because the distance, how do you go from 11 to 5? 11 to 5 पे जाने के लिए, you have to go 6 units to the left. That's -6. You go 6 units more to the left, and that gives you this coordinate, which is -1. So the coordinates of the point E, therefore, are going to be -1 and 4. Right? Is this clear to everyone? How the center's x coordinate was supposed to be exactly in the middle, and then using that we can figure out कि अच्छा इसमें कितना left पे जाना पड़ेगा. In order to go from 11 to 5, we had to go 6 units left. So how do we go from 5 to -1? We go 6 units more left after that. Any issues with this? Momina, is that okay? There's another way of thinking about this as well. If you once you have found the y coordinate for E, you can just input this coordinate in the equation of the circle, right? And find the corresponding x coordinate. आपके पास वहां से क्योंकि वो quadratic है, you will get 2 x coordinates from that. If you were to input y equals 4 here, you'll get 2 values of x. One value of x will be 11, जो point C आपको पहले से पता था, and the other value of x would be -1, which will be the x coordinate of E. तो अब इसको 4 को y equals 4 को आप circle की equation के अंदर भी input कर सकते थे. You'll get the corresponding x coordinate from that as well. But this is a quicker way of thinking of it. Thinking about it, आपको पता है center is exactly in the middle. So you can just use, the distances between those points like this to find the x coordinate of E as well. Okay, so we have a circle with center C, which has equation x minus 8 whole square plus y minus whole square equals 100. This is the equation. In the first part, it says show that the point P is outside the circle. How do you do that? Any idea? Okay, so that's one way of thinking about this. So that's very good. So we have the center of the circle, which is 8 and 4. We have the radius of the circle, that is 10. ठीक है, ये दो चीजें हमारे पास है. We have to show that the point P is outside the circle. What that means is there's a point C here somewhere, which is the center. Let's draw that. This is the circle. C is the center of the circle. We know the radius is 10. So anything inside the circle can have a maximum distance of 10 from the center. 10 से ज़्यादा distance होगा तो it'll have to be outside the circle. So what you do is you find the distance CT. CT distance आप find कर लोगे. C से T का distance using the distance formula. You can say that's 8 minus 6. That's 8 plus 6 whole square plus square root plus 4 minus 6 whole square. You get some value from there. What's that? Anyone? $200? Square root of 200 or just 200? It's square. Right? So that's what you have. Square root of 200. And what's the result from that? It's something greater than 10, right? 14.14. Since we know that CT is greater than the radius, that implies P lies outside the circle. Right? So that would be the reason that you give here. Center से distance का 10 से ज़्यादा है. That is why it lies outside the circle. Okay. Now there are two tangents from T that are drawn to the circle. So two tangents from T to the circle are drawn. Whereas T is outside the circle. So let's quickly do that. This is the center. That's a -6 and +6. Where should that point be? -6, any x coordinate come left side pe, +6 slightly upwards. So this may be somewhere here. Let's say this is the point T. And the coordinates are -6 and 6. Okay, this is the point T that we have. There are two tangents that are drawn to the circle from T. Let's draw those two tangents. One tangent is going to look like this. And the other tangent will look like this. Okay. Now, again, sketching it really helps understand what is going on. So we'll sketch it roughly. I want to part B. Okay, so there's the point B, point T, from which there are two tangents coming. Show that the angle between one of these tangents and CT, what is C? C is the center, and T is that point. Show that this angle is 45 degrees. That's what you have to show. Let's join these 2 points, C and T. If we join C and T as well, we are basically looking for this angle. You can either think of the angle above there or the angle below here. Either of the two, it doesn't really matter. Let's call this theta. We're basically looking for this value of theta. So what we do is we make a triangle here. We draw another line. Or just point over tangent ban raha hai. We make a line here. That's the radius. It's going to make a 90 degrees. Right? This angle is going to be 90 degrees. Once you know that this angle is 90, we also know the radius. The radius from the equation of the circle, that's 10. This radius is 10. We already have the distance CT as well. We found that in the first part. That's 14.14. The distance CT is 14.14. We can find the value of theta from here, right? That's pretty straightforward. It's a right angle triangle. We have the hypotenuse and we have the perpendicular, right? This is the hypotenuse. This is the perpendicular according to this theta. So what we say is sine theta is equal to perpendicular over the hypotenuse. And that is going to give you the value of theta, which will turn out to be 45 degrees. Is that okay? Okay. So that's quite straightforward. Once you understand what the situation looks like, and you can just draw a rough diagram for that. And that will help you think. We know that radius and tangent are perpendicular to each other. So we can just find that angle like that. Okay, now the two tangents touch the circle at A and B. So these are the two tangents that we have. They're saying one of these is called A and the other is called B. We can call any of them A and any of them B. It says, find the equation of the line AB, giving your answer in the form y equals mx plus c. AB की equation चाहिए. How do you find that? Now, it's not very apparent from the figure that I've drawn here because when a rough sketch banaya tha, but once we know that the angle theta is exactly 45 degrees. If this is 45 degrees, what does it mean about this angle? What is this going to be? That's also 45, right? That means this total angle is 90 degrees. यहाँ पे 90 degrees बन रहा होगा. You got a 90 degrees here as well. So what I can do is I can actually make it relatively better now, so we understand the situation better. I need to make it such that we get a 90 degrees here. Maybe roughly like this. I don't know. Let's try. Just to help us think better. So we draw two tangents from there. This is one tangent. This is the other tangent. Okay, so this is almost 90 degrees in the middle. We have found this angle here as well. We know that this is 90 degrees. This was 90, this was 10. We've shown this angle to be 45 degrees. We've shown this angle to be 45 degrees as well. This is theta, and this is also theta. This is the point that is the point A, or let's call any of them A. This is A, let's say, this is point B. What do you think this shape looks like? What is this shape? It's a square because you see this angle is 90. This angle is 90 because it's radius and tangent. This angle is 90 because it's again radius and tangent. We have shown this to be 90. Three angles 90. The sum of angles in a quadrilateral is 360. But the fourth angle also has to be 90. All angles are 90 degrees. There are only two possibilities. Either it's a rectangle or it's a square. But since we know that this is 10 and this is also 10, so the adjacent sides are equal, that means it's a square. Is that okay? Is that okay to everyone? So A, B, C, or not A, B, C, A, T, B, C is a square by all angles are 90 degrees. All sides are equal. So it's a square. What we are basically looking for is the equation for its diagonal. AB की equation चाहिए. What is AB? AB is the diagonal of this square. Square के diagonal की equation चाहिए. Remember the properties of the diagonals of a square? What do we know about that? Diagonal जो होता है square का, what do we know? It passes through the midpoint. It passes through the midpoint, and it is also perpendicular. Right? Does everyone remember that? Diagonals of a square, they cross each other at the midpoint, and they also make 90 degrees with each other. So essentially, all we're looking for is the perpendicular bisector of the line CD. So AB is basically the perpendicular bisector of CT. Right? Because it passes through the midpoint and it makes a 90 degrees. That's exactly the definition of a perpendicular bisector. तो जो CT line है, हमें C के coordinates भी पता है, हमें T के coordinates भी पता है. We don't really need to know the coordinates of A or B for that. Right? We can just find the perpendicular bisector of CT now. And that's pretty straightforward. We have the center's coordinates, which are 8 and 4. We have the coordinates of T, which are given to be -6 and 6. We need to find the perpendicular bisector of CT. What do we need for that? We need the midpoint of CT. That's going to be 8 minus 6 over 2 and 4 plus 6 over 2, which gives us 1 and 5. That's the midpoint. We need the gradient. Gradient of CT, what's that? That's 6 minus 4 divided by -6 minus 8. That gives us 2 over minus 14, which is -1 over 7. If gradient of CT is that, what is the gradient of perpendicular? Gradient of AB. Gradient of AB, which is perpendicular to that, is going to be 7. Okay? We have the gradient, we have a point that lies on the line AB. The equation of AB हम कैसे निकाल लेंगे? We'll just use y minus y1 equals m into x minus x1 now. Equation of AB, that's y minus y1 equals m into x minus x1, which becomes y minus 5 equals 7 into x minus 1. And that's the equation of AB. You can just leave it like that. That's what we were looking for. Good. Let's look at part D now. So it says find the x coordinates of A and B. How do you do that? How do you find the x coordinates of A and B now? What have you found in the previous parts? So we have been asked to find the equation of the line AB in the part before this. Can we use that somehow? Equation of the line AB? Exactly. So we have the equation of a line, equation of the line AB. We have the equation of the circle. We just solve them simultaneously to get the points A and B because they are the points of intersection of the line of the line AB and the circle. उनको बस simultaneously solve कर लें. We have equation of the circle. What is the equation of the circle? That's x minus 8 whole square plus y minus 4 whole square equals 100. That is the equation of the circle. We have the equation of the tangent. You can simplify that here if you want. It's y equals 7x minus 7 plus 5, which is y equals 7x minus 2. That's the equation of the line and the circle. You just solve them simultaneously. You can put this thing here in the first equation. इसका first equation में input कर दें. It becomes x minus 8 whole square plus 7x minus 2 minus 4 whole square equals 100. Now you can solve this equation, right? So it's x square minus 16x plus 64 plus 7x minus 6 whole square equals 100. You simplify this a bit, it becomes x square minus 16x plus 64 plus 49x square minus 12 into 7. What's that? 84x plus 36 minus 100 equals 0. Okay? To simplify this again, it becomes 50x square minus 100x and 0. Yeah, so that's 50x squared minus 100x, that equals 0. And that gives us 50x common into x minus 2 equals 0. So either x equals 0 or x equals 2. These are the x coordinates that we were looking for, x coordinates of the points A and B. Right, so A is on the right, B is on the left. So you can say this is the x coordinate of B, and this is the x coordinate of the point A. Number 14 from the worksheet, I will quickly go through the last part of this because that's slightly different. The first two parts are pretty standard. You have to find the equation of the circle C for which AB is a diameter. What you do is you find the center first. इसका center कैसे find करेंगे if AB is the diameter? Any idea? Any idea about this? Midpoint of AB, right? The center will be the midpoint of AB. Midpoint of AB. You'll find that from there. Radius will be distance over 2, right? So AB का distance आप find कर लेंगे, divided by 2. That will be the radius. You can write down the equation of the circle then. Can anyone tell me what the equation of the circle is? You can just look at the marking scheme and tell me what the results are. Okay, so this is something that you can do. Okay, part B में उसने कहा है find the equation of the tangent to circle C at the point B. So all you have to do is find the gradient of, so let's call the center something, let's call the center of the circle O. Then what you do is gradient of O B find करेंगे because tangent B के ऊपर है, gradient of OB find करेंगे, you'll get something there. Gradient of the tangent will be negative reciprocal of this, right? Negative reciprocal of whatever you got there. That will be the gradient of the tangent. You have the point B. B point आपको given है. B point is 7 and 4. You use that point along with this gradient of tangent to find the equation of the tangent. ठीक है, अब आप निकाल लोगे. What do you get from that? What is the equation of the tangent? Anyone? Okay, so that is the equation of the tangent that you will get in the second part. Okay, so that's pretty straightforward. You can do that. Let's look at the last part. Now in part C, it says, find the equation of the circle, which is the reflection of the circle C. So that's the circle that we're talking about right now, in the line P. So how exactly does this look like? So हम इसको draw कर लेते हैं. That will help us think how it looks like. Let's say this is the circle that we are dealing with. We know the center of the circle. The center of the circle we would have found in the first part. That's 3 and 1. That's the center of the circle. That's somewhere here. This is point O. हमने O का है, 3 and 1. We've got the points A and B. So A, B is the diameter. -1, -2 is going to be on the left side here. Let's say this is point A. -1, -2. Point B is going to be on the other side because AB diameter hai. Let's say this is the point B. B की coordinates are 7 and 4. Okay, so this is the situation. Tangent P is at the point B. So B के ऊपर एक tangent अगर बनाए हम, that tangent is going to look like this. This is the tangent at the point B. इसके अंदर reflection है आपकी, and that's another circle. इसके अंदर reflect होके we have another circle. how do you find the equation of that circle? We have to find the equation of the circle, which is the reflection of C in the line T. This is the line T. इसके अंदर आपकी एक और reflection. Where is that circle going to be? That's going to be on the other side here. That will look like this. उसकी equation आपको निकालनी है. How can you do this? Any idea? What is going to be the radius of that circle? Radius of that circle? It will be the same, right? Because reflection mein, the size of the figure does not change. So whatever was the radius of the first circle, that will be the same as the radius of the first circle, which is 5. First radius ka radius 5 tha, iska radius bhi 5 hoga. The only problem now is, how do you find the center of the other circle? Yes, exactly. That's very good. So B is the point at which we are taking the reflection. No, B is the point at which the tangent is. We have to reflect this point O in this line T. It's going to be on the other side of this point B, the same distance as this. So if we were to go from O to B, O's coordinates are 3 and 1. Coordinates of B are 7 and 4. The center of the other circle, let's call that O2. They are going to be, so what we do is we add 4 here to get 7. So we'll have to add 4 here, 4 more here to get to the other coordinate, x coordinate of the other circle. Similarly here, 1 में कितना add करेंगे तो 4 मिलेगा. We have 3. We add 3 more here, and we get the x and y coordinates for this, which are 11 and 7. ठीक है, हमारे पास center आ गया दूसरे circle का. How? Because we said the distance OB should be the same as the distance O2B, because they are reflections of each other, the circles. जितना distance इसका center left side पे था, दूसरे circle का center उतना ही दूर होगा उस point से on the other side. So that's how we find the coordinates of the other, the coordinates of the center of the other circle. Now we have the coordinates of the center. We have the radius. We just write down the equation of the circle. That's going to be x minus 11 whole squared plus y minus 7 whole squared equals 5 square, which is 25. This is the equation of the other circle. So we have the equation of a circle that is x squared plus y squared minus 8x plus 4y minus 5. So the first part is pretty standard. You have to find the radius of the circle and the coordinates of the center C. What you do for that is you complete the square. Let me just go through the process here very quickly. X squared minus 8x, then you've got the y terms, which are y squared plus 4y. Constant का दूसरे पे ले जाएं, that's 5. Right? You complete the square. How do you do that? You add 4 squared and you also subtract 4 squared. Similarly here, you add 2 squared and you subtract 2 squared. Now you have a completed square from that. You get x minus 4 whole squared from these 3 terms. You've got minus 16 and you get y plus 2 whole square from these 3 terms, and the rest is minus 4. That equals 5. The equation becomes x minus 4 whole square plus y plus 2 whole square equals 25. So you have the center and you have the radius from here. You compare it with the standard form. The center C is 4 and minus 2, and the radius is square root of 25, which is 5. Okay, so that was really straightforward. Let's look at part B. Part B में वो कहता है, the point P lies on the circle. So there's a point P that lies on the circle somewhere. Show that the equation of the tangent to the circle at P is 4y equals 3x plus 5. How do we think about it? Any idea? Equation of the tangent to the circle. How do you find this? No idea? solve simultaneously. We have to find the equation of the line, right? Equation find करनी है आपको. Yes, exactly. So we need the gradient, the equation of a straight line. We need two things for that. We need the gradient of that line and any point lying on the line. We have a point lying on the line that's 1 and 2. Its center काम पे था. The center was 4 and -2. So this is 4 -2. Okay. 1, 2. Where should that be? 1 is on the left of this. 2 is above this. So point P should be somewhere here, right? It helps to uh, mark those points uh, in the correct direction. Otherwise, आपको confuse हो सकते हो उसके ऊपर आप. So P should be on the left of this because उसका x coordinate छोटा है, that's 1, and the y coordinate is bigger, so it should be above this. So P is somewhere on this side. तो आपको पता होना चाहिए किस side के ऊपर है. P is somewhere here. Now you have to find the equation of the tangent passing through P. You have to find the equation of this tangent basically. ठीक है? You know that a tangent is perpendicular to the radius. You can find the gradient of CP. Let's find that. Gradient of CP, what that would be 2 minus -2, which is 2 plus 2, divided by 1 minus 4, and that is 4 over -3, which is -4 over 3. That's the gradient of CP. What about the gradient of the tangent? That would be negative reciprocal of this, right? And that turns out to be 3 over 4. That's the gradient of the tangent. We have the gradient. We have a point on the tangent that is 1 and 2. We can find the equation using y minus y1 equals m into x minus x1, and we get y minus 2 equals 3 over 4 into x minus 1. If we were just asked to find the equation of the tangent, we could just leave it like this. लेकिन यहाँ पे उसने हमें कहा है show that the equation of the tangent is this. We have to convert it to this form, right? 4y left पे होना चाहिए, बाकी सब कुछ right पे होना चाहिए. So what we can do is we can multiply this 4 on the other side. It becomes 4y minus 8 equals 3x minus 3. Let's take that 8 to the left, to the right now. You've got 4y equals 3x plus 5. And that's what you have to show. 4y equals 3x plus 5. That is the equation of the tangent at the point P. Right? Any issues with this? Let's look at part C now. The point Q also lies on the circle. The point Q also lies on the circle. So there's another point, and PQ is parallel to the x-axis. So the line joining P and Q, it's parallel to the x-axis. So it's horizontal. It's a horizontal line. So where should Q be on the circle? Where should Q be? It'll have the same y coordinate as P, right? So it means it has to be at the same level here, horizontally. It'll be on the other side. There's only one other point जहाँ पे की horizontal line cut करती है circle को, and that's this point here. That's where the point Q is going to be. Now, since it's at the same level horizontally, that means that the y-axis of this point, the y-coordinate of this point is going to be 2. Right, so that is 2. What about the x-coordinate now? Can we find that? We've done something similar in our last class, I think. How do you find? Yes, exactly. So we know that the x-coordinate of C is right in the middle. That's 4. X-coordinate of P is 1. 1 to 4 पे जाने के लिए, what do you have to do? You have to add 3. So you add 3 more to get that point on the other side, and that is going to be 7. Okay? So the coordinates of Q therefore are 7 and 2. Is that okay? Because I write down the coordinates of Q. So you don't really need to show any working. आप वो graphically बस show कर दो, या even if you don't show that, write down का मतलब होता है there are no marks for working. You only have marks for writing down the correct coordinates. So एक mark इसमें x coordinate लिखने का होगा, एक mark इसमें y coordinate लिखने का होगा. You don't have to necessarily show any working. So that basically gives you a hint कि ये mentally वैसे ही हो सकता है, and that's how you do it. You say that the y coordinate is the same as the y coordinate of P, and the x coordinate can be found like this, given that C is in the middle, center जो है उसका x coordinate बिल्कुल बिल्कुल उसके दरमियान में होएगा, तो हम Q का x coordinate उसको यूज करके फाइंड कर सकते हैं. Is this okay to everyone? Any issues? Any problems with this? Okay, let's look at part B now. So now it says the tangents to the circle at P and Q, they meet at the point T, और आपको T के coordinates find करना. Okay, I'm going to copy the circle again. Achha, so when you're doing this in an exam, what you should do is you should do these drawings using a pencil. ठीक है? So मैं तो यहाँ पे copy कर सकता हूँ आराम से, right? You don't have a copy paste option when you're doing it using a pen or a pen and paper. अगर आप इसको physically कर रहे हो उस तरह से, you can't do this. So you'll do this using a pencil ताकि आपको ये circles बार-बार नहीं बनाने पड़े. So the problem is if you do everything on the same circle, everything gets cluttered and you get confused. So you do one part, and then for the next part, you erase any information that's not required anymore. So for instance, and once you're done with the second part, you would get rid of this thing, right? इसको आप remove कर दो वहाँ से, इसको आप erase कर दो, and then you draw those tangents that are required there. I can just copy paste and I'm creating a new figure by removing that part. You will be using a pencil, a lead pencil, so that you can erase the parts that you do not need anymore, so that there's not a lot of clutter, because otherwise you can get confused और आपको उस तरह से clearly समझ नहीं आ रही होगी कि क्या हो रहा है वहाँ पे. So I removed whatever I had written above there, and I have two tangents coming from P and Q. So we've got one tangent coming from P, and I have another tangent coming from Q. That looks like this. They meet at some point, and that point where they meet is the point P. What we have to do now is we have to find the coordinates of this point T. इसके coordinates find करने हैं, ठीक है? Any idea about this now? Okay, so that's one idea. What we could do is we already have the equation of one tangent. So you're saying we find the equation of the other tangent and then we equate them, we solve them simultaneously, right? Yeah, so that works. That's perfectly okay. You find the equation of the other tangent as well. You solve them simultaneously. T is the point of intersection. You get that point. Any quicker way of doing this? That's very good and that's very quick. You see, P and Q are at the same level. P and Q, they are at the same level. If I draw a line here that goes from the center to the midpoint of PQ, it makes a 90 degrees. So if PQ was horizontal, this line is going to be vertical. And this is the same line that if I would extend it using the properties of tangents coming from a single point, यही आपके पास line जाके T को भी cut करती है, right? Because it passes through the midpoint of that chord. That's where T is. So T is directly above C, right? T is directly above C. What that means is the x coordinate is going to be the same, right? So x coordinate हमारे पास C का क्या हो गया? That has to be 4. We only need to find the y coordinate now. ठीक है? Y coordinate कैसे find कर सकते हैं? Since the point T lies on the tangent, tangent passing through P. We already have found the equation of the tangent before. उसने हमने निकलवाया 4y equals 3x plus 5. We have that equation. 4y equals 3x plus 5. This was the equation of tangent, which in this case, you can say equation of the line PT. उसकी equation आपको पता है. उसके अंदर आप simply क्या करो? You input x equals 4. X equals 4 पे आपको पता चलता है corresponding value of y क्या है वहाँ पे, right? So you have 4y equals 3 into 4 plus 5, and y is 17 over 4, which is 4.25. So the coordinates of that point P therefore are 4 and 4.25. So the coordinates of 2 points A and B are given, which are -7, 3, and 5, 11. We have to show that the equation of the perpendicular bisector of AB is 3x plus 2y equals 11. I think that's pretty straightforward. So I'm sure Manal would have done that at least. So part B, right? So we have 2 points A and B, -7 and 3 and 5 and 11. You have to find its perpendicular bisector. We have the midpoint of AB. So we might take that to the second part as well. Let's call this M. The midpoint is going to be -1 and 7, right? उस midpoint को use करके, उस gradient को use करके, you have already found the equation of the perpendicular bisector. What is that equation? अच्छा, वो show की हुई है. So that's 3x plus 2y equals 11. You'll get this equation, right? So using this and the gradient of the perpendicular line of AB, आप इसका क्या करोगे? इसका equation निकाल लोगे. You can just write that down here. Gradient of AB क्या आएगा आपका यहाँ से? That will be 8 over 12, which is 2 over 3. So gradient of perpendicular, आपके पास क्या आता है उसका? That would be -3 over 2. You'll be using this along with this point. Use these two things to find the equation of the line. That will turn out to be 3x plus 2y equals 11. Okay, so the rest of you can do it like this. Now let's look at part B of this. Okay, हमने first part में A और B का perpendicular bisector find कर लिया है. That's this thing. Now in the second part it says, the circle passes through A and B, and its center lies on this line. That's 12x minus 5y equals 70. Using this, we have to find an equation of the circle. Now, again, it's going to help if you draw a rough sketch of this figure, of the situation. So you've got the circle. Your पास एक circle है. There are 2 points that lie on the circumference of the circle, which are points A and B. They lie on the circumference of the circle. So point A is -7 and 3. Let's mark that point here. So this is point A. This is -7 and 3. And the other point is 5 and 11. So 5 is on the right, 11 is upwards. So maybe that point is somewhere here, let's say. We don't know. Let's say this is the point, or maybe somewhere here. Let me make a general point. Okay. Diameter na lage aapko galti se wo. Take the other point here. Let's say this is point A, and the coordinates of point A are -7 and 3. And let's say the other point B is here, and the coordinates for that are 5 and 11. These 2 points lie on the circumference of the circle. There's center of the circle somewhere. It may be somewhere here. Let's say यहाँ पे center है circle का. Center के coordinates आपको नहीं पता, but let's call this center C. We have to find the equation of the circle using this information. उसने कहा है circle lies on this line. Circle lies in 12x minus 5y equals 70. This is what is given. Circle lies on this line. What have we found in the first part? We have found the equation of the perpendicular bisector of AB. Now think about that. AB line को अगर हम join करते हैं, फिर हम AB line को join करते हैं, it will look like this. It's a chord, right? This is a chord. What's the midpoint of this chord? We call that point M. Perpendicular bisector इसका कैसा आएगा? It's going to look like this. And remember, a line coming from the center of the circle to the midpoint of a chord makes a 90 degrees. And the other way around is true as well. If there's a line going from the middle that is making a 90 degrees here with the chord, it has to pass through the center of the circle. So the perpendicular bisector AB here, that also passes through the center of the circle. Using that property कि आपके पास जो center से line आती है chord के midpoint के ऊपर, it has to make a 90 degrees. So perpendicular bisector of any chord, so you can sort of just remember it this way. Perpendicular bisector of any chord in a circle passes through the center of the circle. And that's always going to be true from that property कि वो जब midpoint पे cut करते हैं तो 90 बनता है तो वो center से pass करता है. Okay, so what we understand from that is perpendicular bisector of AB also passes through the center. So ऊपर मैंने लिख दिया circle lies on this line. That doesn't make sense. I meant to say center lies on this line. Center of the circle lies on this line. वो उसने आपको बताया था. So center lies on that first line. So perpendicular bisector हमारे पास क्या था? That was 12x minus 5y equals 70. 12x minus 5y equals, no, sorry, that is not what it was. That was 3x plus 2y equals 11. That was the perpendicular bisector that we found in the first part. We have these two things. Circle passes through this line. A center of the circle passes through this line, or the line passes through the center of the circle. And this line also passes through the center of the circle. We have two lines that both pass through the center. How can you find the coordinates of the center now? By solving them simultaneously, right? So we solve these two equations simultaneously, and that's going to give us the coordinates of the center of the circle. And then the rest is straightforward, right? Once you have the center, you can find the distance of that center from either A or B. You will have the radius. You can write down the equation of the circle then. All right, so let's do this. 12x minus 5y equals 70. Okay, so there's azan going on here. I'm just going to take a 1-minute break. In the meantime, I'll just solve this set of simultaneous equations. Okay. Okay, so we solved those two equations simultaneously, right? We had 12x minus 12x minus 5y equals 70 and 3x plus 2y equals 11. I multiplied this by 4 to do elimination. 12x, 12x मैंने same कर दिया, and then I found the values of x and y from there. जो अब मेरे पास x और y की values आई, they represented the coordinates of the center of the circle, which turned out to be 5 and minus 2, right? X equals 5 and y equals minus 2. I got the values of x and y from there. And then once I have the center, once we know the center's coordinates, we know that A and B both lie on the circumference of the circle. We can find the distance of A from C or the distance of B from C. Either of them is going to give us the radius of the circle. So एक कर लिया मैंने 13 आगे radius, then just to input into the standard form of the equation of the circle, and you get the equation of the circle. Discuss this. The point A has coordinates 1 and 5, and the line L has gradient -2/3, and it passes through A. Okay, so there's a line L. It has gradient this, and it passes through that point A. A circle has center 5, 11, and it has radius square root of 52. Show that L is the tangent to the circle at A. How do you show this? How do you show that the line is the tangent to the circle? Any idea? So Manal, no, Laiba, if you asked about the second part, what about part A of this? Part A कैसे करेंगे? Okay, so that's good. So we have to show that it's the line L is a tangent to the circle at A. So there are two things that we have to show. A lies on the circumference of the circle because we're not given that. We're not given that A lies on the circumference. That's the first thing that we have to show, that it lies on the circumference. And the second thing we have to show is that its radius, that its gradient is negative reciprocal of the gradient of the tangent. So let me just explain that using small figures here. This is the circle. It has some center. It has center 5, 11. And the radius is square root of 52. There's a point A, it has coordinates 1 and 5. So it's going to be towards the left and downwards. It's going to be here. This is point A. The coordinates are 1 and 5. It has a gradient of -2/3. अच्छा एक उसने नहीं कहा कि वो सर्कल के ऊपर lie करता है. So एक चीज तो आपको ये show करनी है कि it lies on the circle. How do you do that? How do you show that this point lies on the circle? Distance AC has to be the radius of the circle. So that's good. So that's what we do first. We find the distance AC. AC distance निकाल लें. That's 5 minus 1 whole square plus 11 minus 5 whole square. We get AC equal to 4 square, which is 16, 16 plus 36, which is 52. That's the first thing. We say radius or the distance AC, is equal to the radius. Therefore, A lies on the circumference. Okay, so that's the first thing we have to show here. The second thing would be find the gradient of AC. Gradient of AC. That would be 11 minus 5 divided by 5 minus 1, and that turns out to be 6/4, but that's 3/2. लाइन एल का ग्रेडियंट क्या था, उसने बताया हुआ था, gradient of L was minus 2/3. You say gradient of L the gradient of L is negative reciprocal of the gradient of AC. That implies that L is perpendicular to AC, which is the radius. आपके दो चीजें शो करनी है, right? You show that the distance AC is equal to the radius. That's done. A lies in the circumference. That was one thing that we had to argue or prove. And the second thing was that L is perpendicular to AC. Okay, so therefore, L is a tangent to the circle at A. Now, you don't really have to write such long statements. It's just a 2-mark question. This is just for your own understanding. So when you're looking at the notes, you understand what we're doing. If you show this working clearly, AC आपने radius show कर दिया और आपने show कर दिया these two are negative reciprocal of each other. That's enough proof, right? You don't have to write long explanations. बस आप इसको clearly hint दे दें that you understand what you're doing. अच्छा, let's look at the second part very quickly. Find the equation of the other circle of radius square root of 52, for which line L is also the tangent at A. Okay, so remember we did a similar question yesterday. I think it said something about line of reflection. It's the same idea here. If we draw a tangent here at the point A, that's going to look like this. This is the tangent. This is the tangent, or maybe not. This is the tangent at the point A. ठीक है, अब ये tangent और किस circle का होएगा? इस circle का होगा जो बिल्कुल इसके opposite side पर इस तरह से है. And this circle will be a reflection of the circle. उसका radius ना क्या same है, 52, square root of 52. It's the same radius. It's going to be somewhere here. इसका जो center होएगा, it's called the C2. It's right here. How do you find the coordinates of the center of the circle? Any idea? How do you find the coordinates of the center of the circle? We did that yesterday, I think. Using vector method, A is going to be the midpoint, right? A is going to be the midpoint of C and C2. So we use that. A is the midpoint of the centers of two circles. It's the midpoint of the centers of the two circles. That means if we know the coordinates of the center of the first circle, which were 5 and 11, we know the point A, that's 1 and 5. We can find the center of the other circle by looking at the differences. This is going to be -4. 5 से 1 पे जाने के लिए we have to subtract 4. 11 से 5 पे आने के लिए we have to subtract 6. We do the same thing here. We subtract 4 more. We subtract 6 more. And we get the coordinates of the center of the other circle, which are going to be -3 and -1. This is the center of the other circle. उसने आपको बताया हुआ इसके रेडियस कितना था, square root of 52. You can write down the equation of the circle using this information. You say the equation of the circle is going to be x plus 3 whole square plus y plus 1 whole square equals square root of 52. It's just going to be 52. That's the equation, right? Is that okay to everyone? So that's it for today. If you have any further questions, you can post them on the WhatsApp group or